to finish up our unit on surface area and volume, we are going to be looking at 12.6 and 13.3, which is surface area and volume of spheres. Let's first take a look at the surface area formula for a sphere. This is found on your Keystone formula sheet. So here's your surface area formula, 4 times pi times the radius squared. Notice when we're looking at the surface area formula, it's 4 times the area formula of a circle, which is going to be useful throughout some of our examples. So let's get started here. We're going to find the surface area of this sphere. We're going to round our final answer to the nearest tenth. So the picture that we are given here, notice this line segment is starting in the center and extending to the outer edge. So this 4.5 is representing the radius of the sphere. Surface area is 4 pi r squared. I'm just going to substitute in that radius. So 4 pi 4.5 squared. And you should be able to type that all into your calculator at one time to get a final surface area of 254.5 square inches for that surface area. Okay? Now we are given a sphere. Notice that this line segment is drawn from one side going through the center to the opposite side. So that is representing the diameter. So the diameter is 20 feet. That means that our radius then is 10 feet that we will be using in our formula. So surface area, 4 pi r squared. So 4 pi, radius is 10 squared. Put that all into our calculator and you should get a surface area of 1,256, my mistake, 1,256.6 square feet. Okay, let's keep going. So this one we're given a little bit different directions. We are going to find the surface area still, but we are given the circumference of the great circle. Now when they say great circle, they just mean the biggest circle around the sphere. So we're given that circumference. We are going to use that circumference, 10 pi, to help us find the radius to then help us ultimately find the surface area. So if you recall, your circumference formula is 2 pi r. So we're going to use that to help us find the radius. So replacing the circumference with 10 pi equals 2 pi r. I'm going to divide both sides by 2 pi. So remember when you're dividing, if you're typing this right into the calculator, put everything in parentheses, or you can see that the pi's will simplify out, leaving us with a radius of 5 feet. Now we're going to use that radius of 5 feet in our surface area formula. So surface area is 4 pi r squared. So 4 times pi times 5 squared gives me a final surface area of 314.2 square feet. So that is given circumference first. This next one, they are giving me the area of the great circle. So they're telling me that the area of this great circle is approximately 220 square meters. So recall the area formula is pi r squared. The surface area formula is 4 pi r squared. If I know the area is 220, I know that pi r squared is 220. So that means, like I pointed out earlier, I can replace this pi r squared with just what the area is. So the surface area is just 4 times the area of that great circle that's given. So the surface area is 880 square meters. 4 times that area of that great circle. Okay, let's move on to volume of spheres, and we also are going to be looking at volume of hemispheres. So looking at our Keystone formula sheet, here is our volume formula, 4/3 times pi r cubed. So we haven't seen r cubed yet, so we got to keep in mind that this is going to be r cubed. So we're going to find the volume of this sphere to the nearest tenth. 8, since it's starting at the center and extending to the side, that is our radius. So volume is 4/3 pi r cubed. So 4/3 pi 8 cubed. You can type that in. Again, either put that 4/3 in parentheses or multiply 4 times pi times 8 cubed, then divide by 3, same thing. And our volume is 2,144.7 cubic centimeters. Okay, let's look at this next one. We want to find the volume of the sphere with a great circle circumference of 30 pi. So we have this circumference. We're going to use our circumference to find our radius that we will then substitute into the volume formula. So circumference is 2 pi r, replacing the circumference with 30 pi equals 2 pi r dividing by 2 pi we get that r is 15 centimeters. The volume is 4/3 pi r cubed. So 4/3 pi 15 cubed gives us a volume of 14,137.2 cubic centimeters. Okay, and for this last one, we are looking at a hemisphere. So a hemisphere is the same thing as half of a sphere. So when we're looking at the volume, we can figure out the volume of a full sphere and then divide it by 2. So I'm going to actually show you guys 2 different ways to figure out this volume. Let's go ahead and look at what else is given in my problem. So volume of a hemisphere, half, with a diameter of 35 feet, which means that my radius is 17.5 feet if I take half of that 35. And then we're going to round our final answer to the nearest tenth. So one way to approach this, if I take my regular volume formula, 4/3 pi r cubed, I can substitute in that 17.5 cubed, and you can type that all into your calculator, hit enter, and then divide it by 2 to get your volume of 7,068.6 cubic feet. The other way you can do that, so that's always going to work dividing by 2. I also want to point out how you could change this volume formula for if you're working with a hemisphere. So if I take this 4/3 pi r cubed divided by 2, I can actually divide these numbers. So if I think about 4/3 being divided by 2, that's the same thing as multiplying by the reciprocal or multiplying by 1/2, and I get 4/6. Well, 4/6, that divides to 2/3, so that gives me a new formula for volume of a hemisphere, which would actually just be 2/3 pi r cubed, which that should make sense. Half of 4/3 is 2/3. So you would get the same thing if I take 2/3 pi 17.5 cubed. I would still get that 7,068.6 cubic feet. And that's how you can kind of work with hemispheres or half of a sphere. And that is all for surface area and volume of spheres.